Today we're going to look at how we can take tabular data or text data and information and merge that with an actual GIS shapefile, so adding information to geometry. We're going to use various programs, in this case QGIS, which is an open source GIS platform. We're going to be using 3D Rhino and the Grasshopper plugin, as well as a plugin for Grasshopper called Ada, which you can get from Food for Rhino. This allows you to bring in GIS data into your Rhino workspace. So today, again, we're going to look at how to collect some of this data and bring it into the GIS. One thing to be aware of for any combination of data with shapefiles is that there needs to be a common denominator between the two. So in this case, we're going to use station ID numbers for whatever you decide to use. Just make sure that there is going to be a common reference point. I'll clarify some of that as we get further in, but just be aware of that for whatever you intend to use. So in this case, we are going to use the Clark County Regional Flood Control District information, specifically the weather station and rain gauges throughout the Las Vegas Valley. From this website, we can get multiple things, such as the GIS shapefile. By clicking on the GIS tab, we can go over and look at GIS shapefiles. From here, you'll see a whole variety of shapefiles that they have available to download. For this assignment, we're going to specifically look at the weather station, so all these files. You can download them simply by holding Alt, click the icon, it'll ask you where to download it. I've already downloaded all these files, so I'm not going to do that again. So I'll go ahead and cancel, but make sure you download every single station's file, else it will not cooperate so well in GIS. So once you've done that, you can go over to the Rainfall and Weather tab, click Rain Gauges, then go to Rainfall Summary by Year. And here you'll see a large archive of rain data that they've stored throughout the years. In this case, we're going to look at the years 2015 to 2006, giving us a nice 10-year time span. So what you have to do is select your year and then make sure you click on Show Rainfall so it updates to that year. And from here, you're just going to simply click and drag from Gauge ID 1 all the way down to the page. This may take a second. Go ahead and make sure to end your highlight at the last number. Do Command-C or Control-C. Just to clarify, you can see that this is being organized by gauge ID. This is going to be our common reference point. There's gauge name. You can use that in some cases. However, any type of syntax that may not match can disrupt that matching. You can also see that this data is organized by month. That can be used. However, we're just going to focus on the total rain for the years. This can obviously make this much more robust and extensive, but for this purposes, we're just going to focus on the annual rain data. So once you've copied that, you can go over and choose Notepad and simply paste that in there by doing Control-C or Command-V. Sorry, Control-C, Command-C. Oops. Looks like we want to get rid of that column up there. Not sure what's going on. Try that again. Command V. I don't know why there's a weird space right here. Did I not select it correctly? Let's try that again. Dang it. Let's try from the bottom. Make sure I enter it there. Command C. Okay, that looks better. So let's go ahead. So as you can see, there's really the only thing that's separating these is a nice tab. This is going to be crucial in terms of how we organize this information. So now all you have to do is do File, Save As, and again, you're going to give this name. In this case, I'll just go ahead and save this on the desktop. My weather stations. I'm going to label this 2015. Save. Okay, so you have that finished. Now you're going to go to Excel. What you want to do is first give two column names. In this case, we want to name one that's going to be similar to the shapefile. So I'm going to do station ID 2. The next one I'm going to do 2015 for the year. The next thing you're going to do is go down to the next row, go over to data, and choose from text. Now we're going to look for that text file that we just saved. So 2015, go ahead and import, go to next. So now you'll see that the delimiters are tabs. So that's why that was important to see in that text file, is that now you can see that all these information is separated into their respective columns. Now we can go to hit next. And now we have the option to highlight any columns that we don't want to import and say do not import or skip, leaving us just the station ID number as well as the annual rain data. Hit finish, hit OK. There you go. You can see there's your station ID numbers and then that rain data. I'll move this over just so we can look. So 0, 2.6, 2.8 looks to have come in correctly. So now all we have to do is go to File, Save As, and I'll put this on my desktop. And instead of saving it as an Excel workbook, we want to save this as a CSV, a comma delimited file, or comma separated values. I'm going to label this 2015. I'm going to go ahead and hit save, hit OK, yes, no big deal there. Okay, so we've done enough with the tabs. You're going to essentially repeat these steps for every year that you want to do. So it can be a little tedious, but good thing is that it works. So let's go to our QGIS program. First thing we're going to do is click on this icon to bring in the shapefile. I'm going to scroll down to the stations one that I downloaded, so that AutoCAD one. Hit open, open. There you go. Now you can see that here's all the different stations throughout the valley, even outside into the county edges. Now if I select this, let's drag this one out of here. If I look at this tab on the information, you can see there's a couple columns that may not mean a whole lot to us. Station, station's I, location, elevation, the name. But here's the most important, that station ID column. This is what we're going to use to match our data. So I'm going to go ahead and close this. Now the next thing, so I have my geometry. Now I want to bring in that actual text information, the grain values. So I'm going to click on Add Delimited Text Layer. I choose Browse, find that file I just downloaded or saved, in this case 2015. You'll see that there's the CSV, comma separated values. So I'm going to hit Open. And there you go. You can see that's just those nice two columns. Next thing you want to make sure to do is to make sure that no geometry is selected. That way it understands that it's just tabular data. There isn't any actual location associated with this. Now I can hit OK. And you can see if I click on this tab, again, just a simple chart. So now that we have our data, we have our geometry, now it's time to actually merge that. So if I double click on my stations, I can go over to the Joins tab on the left here. What I need to do is add a layer. In this case, we want to join the layer, which is 2015. The join field, station ID, because that's the one that we want to reference into our shapefile. And then the next one is the target field. That's what we're trying to match with the shapefile, in this case, the station ID. I'm going to go ahead and hit OK, apply, OK. Now when I look at this data, you'll see now that my rain data has been integrated into this shapefile. So you're going to need to do that for all the years that you are planning to visualize. So I'm going to go ahead and close this. I've saved you the trouble of going through that tedious task and already combined that information. So if I click on this again, you'll see here's all that data, so 2006 through 2015. It's going to be important that you do this in chronological order, starting with the earliest year. So here I have 2006 all the way to 2015. You can see in those, here's all those CSV files that I brought in. And the other important thing to do, because we're building off that last assignment, we need to have some kind of reference point to connect our weather station points with our Rhino file. So in this case, pretty much the best one to use was the city limits geometry. If I go over to Rhino now, you can see in your file you should have access to that city limits for this map, and therefore you can use that as your reference point. So let's go back over to QGIS. So once you've actually brought in all that data, you have your city limits, we need to save these as their own separate shape files because they've been edited by adding values to them. So I'm going to just go ahead and right click, do save as, make sure that's an Esri shapefile, hit browse. In this case I saved it as the weather stations 2016 to 2015, hit save, yes, hit OK. And it's going to go ahead and make a copy with that new name that you've just created. I don't really care to have it in here, so I'll just remove it, hit OK. And do the same thing with the city files. So save as, browse, choose the same thing. You can see I already have it there, so I'll just hit cancel. Okay, so now here's the fun part. In Grasshopper inside of Rhino, we can use that plugin that I told you about, Add It, to bring that data into our workspace. So let's go ahead and use the import component, as well as the data viz component. With the import component, you can see that's asking for a path for that file, as well as a Boolean to activate that. So let's go to parameters, primitive file path. Go ahead and drag that in there, right click path, and do set one file path. I'm going to go to that new one that I saved, so I'm going to choose the AutoCAD shape source, hit open, grab my Boolean toggle, drag that into there, true. So from this you can see that there's 238 shapes, those are your weather station points, and then you have all the features. So these features are those columns that are in your shape file. So you can see those first couple columns and then your data. Again, if I look over here, you can see it's the same matching columns. But for this, we really don't need these first 8 rows from Gizmo all the way to station ID. We really just need the actual data from our rain values. So what I can do is go to Set, split this, drag that into my list, and choose what index item I want it to split at. So in this case, we want to split it at 8. So I'm going to go ahead and double click, hold shift for the quotes, at 8, enter. Now you can see when I drag this in, I have the A1, which has those first 8, and I have the B, which is those next 10, which is all that data. So I'll go ahead and delete that. I drag the S value into the O, so this is looking for those shapes. And then I need the features, so B goes into get value features. Now I can just go ahead and drag this to also activate that. From this component, you can see that it's showing possible polygons, P-lines, points, and their associated values. So in this case, they're all just points. There you go, 238 points. And then their associated values. So 238 points, each has 10 values associated with them for the 10 years, gives you the 2,380 values. So you'll notice that in my workspace that it's not here right now. If I orbit and look, you'll see that they're all the way up there. So let's change our view to top, hit zoom extents. You'll see that it's way up here. This is because since the shapefile has designated coordinates, it's going to put those coordinates inside of your workspace. So these are matching whatever the Las Vegas coordinates are. But we obviously need to move those down to our existing file, and that's why we want to also have that city limits file. So let's go ahead and reference that in the same way. I'm going to import to the data viz, use the file path, now I'm going to right click that, say set one file path, and choose the Las Vegas city limits one. I'm going to use the Boolean toggle to activate it. Drag that into there. Doesn't really matter what these features are. We're really just going to be grabbing that geometry. So now you can see that I've turned that on. It's created these geometries of the city limits. It does a little weird thing trying to connect certain parts, but that doesn't really matter. So now we have to figure out how to match this shapefile, the city limits, with the existing ones that we have in our model. And that's pretty simple, actually. So again, let's move over to here. And what you need to do is go to the part where you brought in the shapefile, so you can see that it brought them in as polygons. And I want to double click my canvas and type bounding box. And I'm going to choose the one with points. Let me go ahead and drag that into there. I think it's this one. You'll see that it creates these separate boxes basically for each city limit. I can go ahead and flatten this so it reads it all as one data. And then instead of doing it per object, I'm going to right click this black part and do union box. So it's just all one part. And from here, I'm going to type area. I got in here. And I'm using this not to actually find the size, but rather the centroid or the center point of this. And now also select object, move over to this Rhino space and do the same thing. I want to do a bounding box for this. So I can go ahead and use the curve component, say set multiple curves for those city boundaries. Do the same thing with the bounding box and area. So I'm just going to copy and paste this. And there you see, go. There's your new bounding box and center point. So the good thing about this is now we can basically figure out the direction, switch this, that it takes to get from there to here with our center points. And go over to vector and choose vector from 2 points. I'm going to drag the center point from this one way out in the distance to this one. And you can see that it generates a vector or a direction of that center point out here to there. And that's what we need to use to move all those weather station points, because there's really no reference for them over here. So let's go ahead and do that. Let's use the move component. Again, I'm going to use my points. You can see that it's asking for a motion, or you can see the icon is the same as the vector. I can drag that over here. So you can see that it appears that they're closer. It's just, again, because it came from a shapefile, it's to an actual scale versus our Rhino workspace is at a much smaller scale. You can see I can do the same thing for my city boundaries if I also move those over. Again, it's just going to be so much larger than your workspace. So let's zoom back in. So now we have to actually scale it. I haven't done this before, so we're going to do a little improv. If I know the area of this one is this large, the area of that, that should give me a ratio factor. So let's go to math and divide these factors. So I'm going to divide the small scale by this larger scale, and that should give me a factor of 1.04 to the -7th power. So let's see if that works. Again, I'm going to look at those points, scale them. The center point is going to be the center point of this geometry. And then this is going to be our factor. That does not appear to have worked. So, interesting. Okay. So let's just delete that. So in this case, the factor is going to be, I've done this quite a few times. So I know it's like 0.0035. That should get us pretty close. Again, I'm assuming this is the right scale. Obviously, the best way to do that is to scale the city limit boundaries. So in this case, that might actually, I don't see where they've gone. Is that too much? That is the right one. Let's turn off some of the stuff. Maybe it's just blocking it. Oh, it's because I forgot to move it. scaling it all the way up there. Let's move that back to 0.35, 0.00035. Let's go ahead and copy that and scale this. There we go. So it looks like it's still a little too big if I highlight it. So it looks like it's right there within the ballpark. That should be good enough for this case. I mean, we could always try and get a little bit closer, but looks like their projections aren't exactly matching perfectly, but this should work well. Okay, so basically if we know that this factor, scale factor is working, then this should also work for our weather data. So there you go. Now you more or less have these weather stations brought into your base map. The next part of this video is going over to visualize this information. That's going to be it for now though, so check out the next video to begin visualizing this data from a series of years.